Hello everyone. Today we are going to present a case study on a situation in an electric scooter company. So let's see the questions related to the question number 1. What are some of the design consideration you would have for designing the storage feature and what all will you need to consider for security of documents while designing the architecture? The solution is first, design considerations, seamless integration, incorporate native gallery and camera across within the app for quick uploads, minimum UI steps, keep the upload process under 3 taps to avoid friction, optimized format handling, auto convert less common formats into supported types for consistency, adaptive sync, use background sync that prioritize Wi-Fi or strong network conditions, smart file naming, auto label uploaded files using date or location metadata. Second, security considerations, end-to-end encryption, implement encryption at both transit and rest, granular permissions, role-based access to control who can view or edit or share files, secure session, handling, use token-based authentication with short experience windows, redundancy and backup, use cloud services with built-in redundancy, example AWS S3 versioning. Tamper detection, log every access or change with alert triggers for anomalies. So let's move towards the second question. List the potential regions for any two of the issues which the customers have complained about and write the test scenarios you would use to test and ensure they have been fixed. Issue first, scooter battery dies suddenly. Root cause, poor state of charge estimation algorithm. Environmental impact, example cold weather affecting battery. Test scenarios, simulate extreme weather and monitor battery discharge, drive varied terrain and cross-check predicted versus actual range. Second issue, delayed and outdated app data. Root cause, latency in server-side data processing, poor retry logic in case of weak networks. Test scenarios, use networking throttling tools to simulate edge cases, benchmark real-time data flow from scooter, cloud,
So now let's
and
understand the question 3. The company would like the app to have intelligence and provide recommendation to the driver. What kind of data should the app collect from the vehicle and what kind of recommendations can be done? Is there a possibility to use ML or AI for this analysis, and if so, what can be the use cases? So now let's understand what can be the data can be collected. So first is the powertrain health matrices, real-time location and terrain info, charging behavior, that is speed, time and frequency, emergency brake frequency, users travel patterns and timings, and etc. And the next one is the recommendations. What can be the recommendations be done? Recommendations can be like predictive maintenance from smart route suggestions, avoiding traffic hills or something. And the third one can be the personalized eco mode configuration, off peak charging alerts for cheaper rates. And now let's understand the AIML use cases. First is we can use clustering, where we can group rider types, example commuters versus delivery. The second is the regression, where we can predict battery wear based on usage. The third is the classification method, where we can detect unsafe driving patterns. And the last is the recommendation system, where we can suggest personalized app setting. So this was about the question 3. So now let's move towards the question 4. So the question 4 says that what can be the business and operational matrices and measurements the company can use for the new versions of the vehicle and the goals they have for it. So now let's understand the business metrics. So first is the retention rate. We can check whether the users are sticking to that brand after 6 months also, like whether they are coming again after 6 months to the brand or not. The second one is the net promoter score, which stands for NPS, where we can gauge overall customer satisfaction. And the upsell ratio is about our users buying accessories or upgrading it. And the last one is the customer lifetime value, that is CLV, where profit per projection per user is done. So now let's understand the operational matrices of this. So first is the battery efficiency per kilometer hour, which is very useful for operational matrices. The second one is the repair incident rate in the first 90 days. The third one is the support ticket value related to app or scooter integration. The fourth one is the firmware update success rate. And the fifth one is bug fix turnaround time, that is what amount of time does it require to fix the bug. And the last one is the firmware patch adoption rate, where we calculate the adoption rate of it.
So now let's discuss question number 5. Question number 5 is use the inside out and outside in technique of releasing a product to the market and list the top 5 things you would do inside out planning to release the new app to the market and outside in planning for releasing the new app. Inside out planning, company centric approach. First is define scalable architecture. Finalize the app's tech stack for stability and future growth. Example, you can choose React Native, Node.js or Firebase. Second is cross-platform internal testing. Conduct rigorous QA across different devices, OS versions and screen size. This induct that our product will work across every device. Third is team enablement and SOPs. Create documentation and internal SOPs for devs, supports and testers. Fourth is release management and rollout strategy. Plan phase rollout, alpha, beta and gradual public rollout. These are the testing routes. Fifth is monitoring and analytics setups. Define KPIs, user retention, crashes, feature engagement and alert for anomalies. And next is conduct real world beta trials. Select early adopters from different user segments. Gather structured feedback on usability, performance and pain points. Next is use user journey mapping. Identify key use cases just as commutator, delivery or casual rider. Fourth and last is marketing and positioning plan. Craft clear messaging. What makes the app better? What should users care? Prepare launch campaigns for social media, app stores and scooter dealerships. And now question 6 is the company is collecting the data in cloud already but have had performance issues to update, collect and data and update the app. What can be the reasons for that and what would need to be improved for the data integration from the vehicle to the cloud and to send the data post analysis to the app. Cloud performance issues and solutions. Unstable data transmission from vehicle. Reason, the scooter may lose network and lose network signal during the ride. Subpoint, this cause incomplete or delayed data uploads to the cloud. Inefficient cloud infrastructure. Reason, the backend server may be overloaded and not regionally distributed. Subpoint, this results in high latency. And slow response times. Fourth is unoptimized data format and payloads. Large and unnecessary data is being sent frequently. This increases processing time and affects overall app speed. Fifth is delayed post-processing in the cloud. Reason, data analysis takes long before updates are sent to the app. The app shows outdated info because real-time updates are waiting for full processing.
Okay, so the next question is seventh, that is the research on the evaluation of the domain of electric vehicles and represent it on one slide is an impactful way on what has been the evaluation and where you think it will be 10 years from now and what kind of feature functions will be available. How has the technology evolved and what is the direction of this technology? The next answer is evaluation of electric vehicle, that is EVs, past before 2010, low range and speed, high cost and low adaptation, basic battery tech. Now present, that is 2010 to 2025, that is improved range, that is 300 plus kilometer, government incentives and charging infrastructure, app integration and smart features in the future, that is from 2025 to 2035, that is fast charging under 10 minutes, self-driving with AI, energy sharing, predictive maintenance and AR dashboards and smart city sync. The last question, that is what do you think are the businesses metrics which are being used by the company to decide what to focus on for improvements and changes? What engineering matrices and measurements do you think should be looked at considering the complaints from customers? Do also give the reason for the metrics and measurements you have selected. The first one is business metrics, customer satisfaction. Measures customer contentment after interactions. High CSAT indicates that needs are met. Second one is Net Promoter Score, that is NPS. Measures customer loyalty by asking if they would recommend the product. Low NPS suggested areas for improvement. Next one is customer retention rate, that is tracks the percentage of returning customers. High retention signals product value. Fourth one is crunch rate, that is measures customers who stop using the product. High crunch indicates dissatisfaction. Fifth one is revenue and growth metrics. Monitors financial performance and helps allocate resources to high impact areas. Next one is engineering metrics. First one is System uptime and availability. Ensures reliability, frequent downtimes lead to customer frustration. Second one is response time latency. Measures speed, slow response time degrade user's experience. Next one is error rates, tracks system errors. High rates correlate with poor user experience. Fourth one is throughput and scalability. Measures system capacity to handle increasing users or requests. Thank you.